Okay, good morning everybody. I will talk about flexible distributed checkpoint restart in Kerrighed. This is a French way to pronounce it. Okay, so this work is done in the context of two research projects, one French national project, PITAC-CD, and one European project, ExtremeOS. Okay, so what is Kerrighed? Kerrighed is a single system image operating system cluster, operating system for cluster. So what does it mean? It means that you have the illusion of a virtual SMP computer on top of your cluster. So you have a global view of your process, you can kill it, you can monitor it with PS, with pgrep, with what you want. This is just like a standard Linux box. You have global memory, so you have shared memory, shared IPC memory segment, and you can have a process that use more memory than the memory on one node. We are currently working on node addition and removal. We expect it to have it before the end of the year or before the summer. And there is also application checkpointing. This is the main part of my talk. Kerrighed is implemented as a quite big kernel patch. There is also some modules, mainly for scheduling, and a small set of user learn tools. The development version is currently based on Linux 2.6.30. And now, in this development version, Kerrighed is implemented as a lightweight container. Okay, so what is checkpoint restart? Checkpoint restart is a checkpoint is the ability to save the state of a running application on the disk. Then you can restart your application. So you restart your application from your checkpoint and you have exactly the application in the same state as before. But in the meantime, you have perhaps shut down your cluster, shut down your computer, or so on. What is it useful? It is useful for fault tolerance because your cluster will not run for every, if you have long running jobs, you will have failure on your cluster. And so this can be useful. This is also useful for scheduling because when you start long running jobs, maybe you will have to stop them because you have some other job to run. This is useful also for hardware maintenance and for debugging. Okay, so now what are the checkpoint steps? This is common to all checkpointers, all system checkpointers. First, you have to freeze your application. Then you will dump the data, you will dump the process memory, the register, and so on all the internal state of the application. And finally, you will let your application resume. Well, these steps are needed at kernel level for consistency, because if you checkpoint the process without stopping first the application, your application will not be, you won't be able to restart it consistently. Okay. But this is needed at kernel level, but this is also useful at user level. Why? Because the kernel can't do all for you. So, for example, generally, file system is not saved automatically when you checkpoint your application. That means that you have to do it yourself. So you have to select the file you want to copy, for instance, with your checkpoint. So you need, at one moment, to freeze your application, be able to copy the file, for example, and then to really checkpoint your application. Okay, now at restart, it's a little bit simpler. So first you restart your application will be restarted frozen, and then you just unfreeze it. So again, it is needed at kernel level for consistency, because you can't let some process resume before other processes of your application are restored. And but this is also useful at user level. Okay. Now, simple, no, okay. So what is an application? All checkpointers do not have the same concept of application. For all checkpointers, an application is only one process. In Kerrighed, an application is not one process, it's not one process group, it's not a tree of process, but it's a set of process. So for instance, if you imagine this application, here you have 3 processes, 1 process, 2 processes, and here you have a multi-threaded process. If this process stops, and those processes are reparented to init, that doesn't mean that they are not in the same application. In Kerrighed, those processes are still seen as being in the same application. This is generally not the case in other checkpointers. Okay, so you have an application, but an application is not only processes, it's also files. You need files for your application. Those files are mainly the terminal, but this can be open files, this can be map files, and so on. And of course, your processes are probably communicating together with pipe, socket, IPC object, and so on. So the limits of an application evolve during the life of your application. It evolves with fork, with exit, with open, with mmap, and so on. Okay, our first example. So this is an example of an application that reads data from an IPC message queue. So you start your application with the following command line. So you have, if you are your shell, then it creates some process, maybe a multi-threaded process. And this process will read data from an IPC message queue and will write data in those files. Okay, so before starting your application in Kerrighed, you will need to inform the kernel that it will be an application that will be checkpointable. If you don't do that, we have no way to know that this is an application, and the result, if you don't do that, will be to checkpoint the whole system, and you don't want to do that. So you just added this at the beginning of your command line. Unlike BLCR checkpointer, it's not to do some hijacking of your process. In BLCR, for example, there is a similar way to run your application, but the goal is to make your application load some library without knowing it. Okay, so now you want to checkpoint your application. First, you will ask for freezing your application. So you identify your application with one PID of the application. Once you have freeze your application and you are sure that that your application is not reading data from the message queue, you can checkpoint the message queue. So you will save the content of the message queue with the following command. Then perhaps you need to save the content of this file. Maybe not, but maybe you need. So if you need, you will simply maybe copy it by yourself. Once you have done all these preliminary steps, you will be able to checkpoint your application. So here it's just to say, okay, now I checkpoint, and then you say, okay, I can unfreeze. So your application will continue, but you have a safe checkpoint that you will be able to restart. So now, if for some reason you have rebooted your computer, or I don't know, and you want to restart your application, first you copy the file back, you restart the message queue, and then you restart your application. Okay. Now, a much complex application. So an OpenMPI application. Okay, this we are using it for physical computation in quantum chromodynamics in a project. Okay, this is for long-running jobs, of course. Okay, so you start your application with MPI run, with a host file that says, okay, I want to run my application on this node and on this one. And here is your application. So this is standard OpenMPI. Then in OpenMPI, you have a way to checkpoint your application. So you identify your application with the PID of MPI run. Okay, I just forget to explain how the application is started exactly. Okay, so you run MPI run, then MPI run will establish SSH communication through the different nodes specified in the host file. On the other node, some orted process will be started. And then MPI run and orted will fork and execute your computation process. Then your computation process will discuss together through the MPI layer. So this is morely sockets, but probably your process will write on some files. Those files may be shared with MPI run or with orted, or maybe not. And there is some pipes open between MPI run and your computation process, and similarly with orted. Okay, so you ask to checkpoint your application. I will just go further. Okay, in OpenMPI, the fact is that OMPI restart is just a wrapper to MPI run. This allows you to restart your OpenMPI application on perhaps more node or less node than before. So in fact, the system checkpointer will only be used to checkpoint your computation process on MPI run. And OpenMPI is responsible to reopen the sockets and so on. So, okay, no, it's not this one. Okay, so for restart, as you see, you specify again the host, you again specify the number of process, and you identify your checkpoint. So in fact, since OpenMPI creates back the socket communication, you don't have to do it yourself in the checkpointer, and you have to replace it. You have to get it from MPI run or orted, and you have to replace it. OpenMPI is basically designed, OpenMPI checkpointer is designed for BLCR system checkpointing at the beginning. And we have tried to make it to have a better interface than BLCR. Because the interface for file substitution in BLCR is not very good. Okay, so it's fast. It's now time to conclude. So why is the checkpoint in Kerrighed is flexible? It's flexible because you can checkpoint a set of process. Those processes may be multi-threaded or not. You have freeze and unfreeze like other checkpointer. As I say, it's needed for the user. In Kerrighed, we are able to save and to restore IPC objects such as message queue in my example, but also shared memory segment or semaphore. You are able to save it independently because you need the user to know which IPC object to save. From the kernel, you don't know which IPC object are used in your application. Okay, we are able to restart the application in background or even foreground. We are able to do some file substitution at restart, so that means that we are able to relink your application to a new socket. And finally, we are able to do some process group and session ID substitution. Again, it was needed in the OpenMPI case. So, and then why the checkpoint restart is distributed in Kerrighed? Simply because Kerrighed is an operating system for cluster. That means that a simple tree of process may be distributed over the cluster. So your application can be distributed. And then, but perhaps you also run some application really dedicated, really for clusters such as OpenMPI application, and we are able to checkpoint it. So this is my end of my talk. I have about a few seconds if you have perhaps one question, I don't know. Or if you have more, probably we can discuss at the bar. Okay? Yes? Sure.
Is it in production or is it in a test farm?
The checkpoint restart, you mean, or the Kerrighed deployment?
Kerrighed deployment.
I guess there is some production system at EDF. Yes.
Can I propose that you meet the speaker next to the, because here at the lightning talk